that like I did in chemistry last week. Oh, come on, interweb. Oh, that's going to be slow. Oh, there we go. 6. That sounds good. What button am I looking for? There we go. All right. On Friday, we finished some graphing and started going over this. I don't know if any of you can hear me. Oh, oh, okay. And sometimes the headphone jack if I move and I didn't hear anything. Thank you. Um, I think I did all of that on Friday. I did this morning. Rewrite in exponential form. C to the G equals P. The base to the exponent is that, and B log base B of M equals R. We did all of that on Friday. I filled in some of these. Log base 4 of 16, 4 squared is 16, 25 to the 1 half is 5, 3 to the negative 2 is 1 ninth, 16 to the 7th is, well, 16 is 2 to the 4th, to the 7th is 2 to the 28th. Whew, big number. Log base anything of 1 is 0. Log base 8 of 8, log base something of the same thing is uh, 1. Log base 3 of the square root of 27. So I had to convert that into the exponential form. 3 to a power equals 27 to the 1 half. Well, I recognize that 27 is 3 cubed. And then, whoops, when I multiply my exponents, 3 times a half, so x is 3 times a half, and we'll actually look at a way to do that without doing all of this. Ln of e is 1, log of 10 is 1, log of 10 to the 5th, well, is 10 to what power is 10 to the 5th is 5, ln of e to the 9th is 9, and so on. Then the base function for y equals 3 log base 4 of negative of x plus 2 minus 1 is log base 4 of x. The mapping rule is negative x plus or negative x minus 2 and 3y minus 1, which gives a vertical asymptote at negative 2 in this graph because it's got a reflection in the y. Our normal logs look like that. So if I'm reflecting in the y-axis, it's going to look something over there. Draw the graph of the function log base 2 log base 3 of x plus 1. The base is log base 3 of x. So here's my original table. And then I did my mapping rule of x minus 1, 2y plus 3. I had to fix that it's 1 and 0, not 0 and 0. So that maps to negative 2/3, 0, 3, and 2/5. This one has an x-intercept somewhere before or to the left of negative 2/3. The y-intercept is easy, 0 and 3. Domain x is greater than negative 1. Y is part of the reals. So I'll put that up in a minute. So RF10 is called laws of logarithms. And these are like the laws of exponents. And because of this whole thing, and I don't have a class, down at the bottom there's the three that are the most common, I guess. There's kind of examples of how they work out. I stole this from somebody different because I liked it better than something else. Log base 5 of 25 is 2. Oh, log base 4 of the cube root of 4. 4 equals x, so 4 to the x equals 4. Well, if it's a cube root to the 1/3, x is 1/3. X to the half equals 9. What do I have to raise or square root? Because the other way is to get rid of that is square both sides. X equals 81. So the three laws of logarithms are the multiplication or product rule or law. If you have the log of a product, x times y, I can separate that and say it's log of x plus log of y. So, and we'll look at an example here in a second. I can go the other direction. If I have a sum of logs, I can write it as a product. Adding and subtracting, multiplying, dividing are kind of the same. So if it's a quotient, I can write it as, so let's see, log base 2 of 8. Well, we know 2 to what power is 8? 2 to the third power. But if I take 8, I can say that is log spacing. 8 is 2 times 4. Log base 2 of 2 plus log base 2 of 4. Log base 2 of 2 is 1. Log base 2 of 4 is 2. 1 plus 3 equals 2. 1 plus 2 equals 3. Sorry. It will work the same as a quotient. Oh, let's do 27 because log base 3 of 27. Well, no, 27. That's not the number I'm looking for. Oh, I had one in a second. Log base 3, because when I wanted to use something different than log base 2. 27 is, yeah. Log base 3 of 27. 27, no, no. Log base 3 of 9. There we go. 27 divided by 3 is 9. If I split that up, log base 3 of 27 minus log base 3 of 3, well, that is 2. This is 3 minus 1. 3 minus 1 equals 2. We've used, this is the one that comes in the most handy. If you have an exponent, you effectively can drop the exponent in front and then simplify that log and multiply. And this is that, oh gosh, what was it? E to the 5 ln of 2. Oops. Well, I can take this and go the opposite way and put that up. E to the ln. Oh no, it was 2 and 5. Sorry. 2 ln 5. If I move that up there, I get 5 squared, which is 25. So that was 25. That's the law that I was trying to use. This one you have to be a little bit careful because this is log base b of x to the power of n. That will work. If you have log base b of x to that, those are two different things. Not equivalent. You can't do anything. So today we're just going to look at some expressions. Sorry. Write as a simple or a single logarithmic form, which is usually fairly straightforward. Write as a single log. Then we can get all of these crazy things and evaluate. And we'll see how far we have some time. Log of 5 plus log of 12. If I have an addition, this is going to equal log of 5 times 12. Log of, well, 5 times 12 is 60. That's is normally you can do these either way. It just depends on what sort of thing you're looking for. If you like calculator proof, the log of 5 is 0.69897. The log of 12 is 1.07918 plus 0.66897. So that is about 1.778. 60 log 1.778. There's some rounding error, but that's going to work out in your favor. Log base 6 of 10 plus log base 6 of 18 minus log base 6 of 5. We have to do this kind of in the order in which it occurs. So I'm going to do this part first. Log base 6, 10, and 18. Log base 6 of 5. Well, this is log base 6 of 180. Well, now I have a subtraction of 180 divided by 5. 5 goes into 18 3 times. With 30, 5 goes into 30 6 times. Oh, well, what power do you raise 6 to get 36? 2. So, well, geez, that whole crazy expression, if it came out of some sort of calculus business, blah, 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 and the answer is 2. 2 is significantly simpler than something like that. Can I do this kind of all in one step? Those are a product. Log of 10 times 18. That's a subtract over 5. That's also going to give you log of 36. It gives you the same thing. 10 over 5 is 2 times 18. So you can kind of do them in the same in whatever order you want, which is what a lot of people are going to do with a question like this. It's all logs. I've got to subtract, so I have that in the denominator, plus a, because I can move those around, log of a plus log of b plus log of d, a, b, d over c. There's This involves the power law now because there's this 2 here, you can't just do x over x plus 3 because this is 2 times that. So the first step here is to use the power law to say this is log base 4 of x squared minus log base 4 of x plus 3. We'll throw a bracket around that as well. So now I have log base 4 of something minus log base 4 of something else. Log base 4 of a fraction. X squared is the numerator. X plus 3 is the denominator. So we simplify, and then you can do your bit. These are kind of algebraic type rules. It's about being able to manipulate things to make your life easier. Do I know the exact values of the log base 6 of 10 and the log base 6 of 18? No, I don't particularly care. If I can manipulate things and give myself a number, that makes things a little bit easier. So that's the first little bit. Uh-oh, right is a single logarithm. Same idea. I've got to move those up using the power rule first. Log of x cubed plus log of the square root of x minus 1 squared. Square and square roots cancel. Well, that makes things a little bit easier. Log of x cubed plus log x minus 1 log of x cubed onto x minus 1. Can I expand that if I really wanted to? Most people are probably going to stop at that spot. Log of x to the 4th minus x cubed, depending on what you're trying to do or anything like that. We can get into there. Oh dear, we get all sorts of plus. That's a little bit interesting. 3. So I have a number here. I want it as a single logarithm. Everything else is log base 2 of something equals 3. Can I put a logarithm in for this? 2 cubed is 8. So I would say, well, a half log base 2 of x minus 4 log base 2 of the square root of y plus, well, 3 is log base 2 of 8. I would do that to make, because if I don't set a number to its logarithmic equivalent, 3 is log base 2 of 8. If this was log base 10, you could put it whichever number you needed. So now we have to use the power rule to get rid of the half in the front. Log base 2 of x to the 1/2 minus 4, no, minus log base 2 of the square root of y to the fourth, log base 2 of 8, nothing there. The square root of something to the fourth, that I'm going to do something to, because we know from, if I have the square root of y to the fourth, well, this is y, the square root is to the half, to the fourth, 4 times a half, so this is going to equal y squared. So I'm going to make my life a little bit easier. X to the half minus, this is log base 2 of y squared, log base 2 of 8. Can I write that as a radical? Sure, but I've got a subtraction, log base 2, the subtract part, y squared. I would say 8x to the 1/2, or if you wanted to use radicals, log base 2 of 8 root x. Oh no, bad, bad, x over y squared. So it's a manipulation thing. It's just moving things. Could this be particularly easier to use? Potentially, or that. Or you can have some kind of intermediate form. Oh, evaluate. We'll probably do these two and leave a little bit for tomorrow. So if you're evaluating something like this, your first step is most likely write it as a single logarithm. So I'm going to, just because I'm going to change colors, I'm going to move my coefficients, make them exponents using the power rule. Log base 3 of 6 cubed minus log base 3 of 2 to the fourth plus log base 3 of 4 to the 1/2. 6, 2, and 4, none of them have anything to do with the power. They're not related to a power of 3. Oh, 6 sixes are 36, 180 plus 36 is, oh, but I can evaluate that. That's 216. 2 to the fourth is 2, 4, 8, 16 plus 4 to the 1/2 is 2. Log base 3 of 216, that's a plus, so times 2 divided by 16. It's too early in the morning for me to try to do that in my head. 216 times 2 is that divided by 16. Oh, log base 3 of 27. What power can I raise 3 to get 27? Trace. So it's algebraic. No, this isn't even. It's algebraic manipulation a little bit. Oh my gosh. We'll stop with this one. This one looks bananas. It's log base 5, log base 2, log base 3. Interesting. Isn't this going to be fun? As an exponent, log base 5, I'm going to 125, that's to the quarter, to the 2/3, minus, I'm going to put that up there, log base 2 of, oh, I'm going to use rational exponents, 32 to the half cubed plus log base 3 of 81 to the fourth to the half. Oh dear. 1 times those are going to cancel, so log base 5. 2 over 12 is to the 1/6. Oh. There may be a totally different way to do this, but it's going to end up with about the same answer, I hope. This is actually, yeah, it's going to make, it doesn't make a whole lot of difference. Because we see these pluses and minuses, we actually don't have to do anything with them. Log base, so this is log base 2 of 32 to the 3 halves, log base 3 of 81 squared. So where I would go next is 125. I can express that as a power of 5. 32, I can express it as a power of 2. 81, I can express it as a power of 3. Log base 5 of 5. This is probably what I should have, potentially what I should have done. 5 times 5 is 25. That's 5 cubed to the 1/6 minus 2, 4, 8, 16, 32. Log base 2 of 2 to the 5th to the 3 halves. Log base 3 of 3 to the 4th squared. Log base 5, that's going to be to the 5 to the 1/2. 15 over 2. And log base 3 of 3 to the 8th. A half minus log base 2 of 2 is that, so the a half minus 15 over 2 plus 8. Well, that's a half minus 15 over 2 plus 16 over 2, which is 1 minus 15 plus 16 all over 2. 16 minus 15 is 1 plus 1 is wow, that whole ugly messy business is 1. Hindsight, there's a couple of things. I think I would have done something like this way back at the beginning. Probably would have made life a little bit easier. We'll look at that one again tomorrow and the rest of those two. But those are some examples of the power rule. 7 of you on a Monday morning. Is there any questions? That was a little bit quick. I'll try to find some more examples of those to go over tomorrow. Um, just because these are, would you get a day and a half to practice if you were in school? Yeah, so we've got to find some way to do that. Those are some kind of messy ones. We'll find a couple simpler ones to look at tomorrow and go through and practice. But that's kind of where I would stop today. If no one has any questions, I'll hang up and you guys can enjoy your afternoon. Sound good?
Thank you, Mr. McGrath.
You're welcome.
Thank you.
Welcome. Have a good day.
Thank you.
No problem.